Okay, well students, today we start with chapter 6, triangles. Very important chapter for exam point of view. Now concentrate, and if you have any doubts, let me know. So first of all, before I start the topic, we have to understand few things. In this chapter we will learn about this. If you observe, these two are both are triangles, right? These two are triangles, but the figure are known as, what are the figure known as? Similarly, this is a square, and if I'm telling this is also a square, and both are square, right? But if I'm telling this is triangle, and again this is triangle of same size, so we will be learning in this chapter about similar triangles, which is this. If they are similar, the cosine is this. Similar, they are similar figures. Symbol is this. They are similar figures. They are similar. In 9th standard, we have learned about congruency. This is congruent because exactly same. This is similar. Okay, similar means the shape is same but the size is different. The shape is same but the size is different. But congruence means they will overlap each other. So overlapping, if they are overlapping each other, it means they are congruent figure. For example, if I draw a square, same size square I draw, they are overlapping each other, so they are congruent. This is a symbol of congruent, already you have learned. This is a symbol of similar triangle. So in this chapter we will discuss in detail about similar figures. So very important. So understand this, how the figures are similar. Okay, in this already we have learned about congruency. In congruency we have learned when the figure can be congruent. There is property side angle side, angle side angle, right? Side, angle side, then RHS. These are all the properties of similar congruent triangles, right? Of congruent triangles, of congruency, all these properties are the SAS, ASS, ASA, SSS, AAS, RHS. Okay, so this also properties will be there for similar triangles. So proving any two triangles similar, these properties will be there. But one more property will be added in similar triangle is angle also. So this is the new property which will be used for proving any two triangles similar. If two angles are equal, we can say that triangle is similar. Okay, if you see in textbook it is already given. So let me just show you. These are examples. See, these are similars, right? Similar figure. This is also circle, this is also circle, this also have same shape, this is also same shape, right? So if similarly, if you observe, they are same shape. So if you observe, if they are similar in shape, they are known as similar. This also similar shapes, right? All are Taj Mahal, but they are what? All are rectangle in shape, so they are similar in shape. So we'll discuss this. So in first exercise only the basic things are there. Now how to understand a triangle is similar. In order to find, if you want to check, how to check the triangle is similar. Because by observing you can say, sir, it is similar. Okay. But how you will prove it? By solving. Observation we cannot write, right? By observing we cannot write directly it is similar. So in order to understand any figure, how can you find that? I can say that the figure is similar. For example, this A, B, C, P, Q, R. So for any figure to be similar, if this is a square also, for example, A, B, C, D, and here P, Q, R, S. How can we say both are square? Because by observation you say that it is a square, but how can you say they are a square only and they are similar shape? So very simple, simple formula it is. If they are proportional, it means, for example, here it is 3, and here it is, let's say, 4, and here it is 8, and for example 6, 8, 16. Okay, if you check AB upon PQ, AB upon PQ equal to BC upon QR, BC upon QR, and AC upon PR, AC upon PR. So if all sides are proportional, AB is what? 3, PQ is what? 6, BC is what? 4, QR is what? 8. AC is what? 8 and PR is what? 16. If you observe, if I are dividing all the sides, I'm getting answer 1/2. So in order to find that the figure is similar or not, if the sides should be proportional to each other. I'm observing all are 1/2, 1/2, 1/2. That's why I can say they are proportional. For example, it is, if it is not equal, then we cannot say it is similar. All sides should be proportional to each other. Okay. So for first thing is this, for any triangle or any figure to be similar is, first thing is proportional. They should be proportional. And second things, all angles should be equal. All angles should be equal. Then we can say the figure is similar. So two things you have to check for any triangle to be similar or any figure to be similar is, one thing it should be proportional, and the second thing it should have all angles equal. For example, in this case, if I take 2, 3, 4, 5, and here let's say I will take 4, 6, 8 and 10. If you observe, the figure is again similar, because here AB upon PQ is equal to AD upon PS is equal to DC upon SR equal to BC upon QR. And all the answer is again coming 1/2, because AB is what? 5/10. AD is what? 2/4. PC is what? It's DC is what? 3/6. BC is what? 4/8. If you observe all answers, you are getting 1/2, or else here only 1/2, 1/2, 1/2, 1/2. So very important thing, how to understand, how to find that the figure is a similar, not by observation. We have to solve. So how to solve? First thing you will check, is there all the sides proportional or not? Proportional means answer by dividing all the sides, are you getting same answer and all angles equal or not? For example, if they are having proportional, but if the angle is different, here it is 90 degree and here it is, let's say 85 degree, so then they are not similar. Angles should also be equal. So for making any two shapes to be similar, it should have all sides proportional and all angles should be equal. Okay, this is the property of a similar triangles or similar shape. So in the first exercise, we will be just discussing about the similar shapes, not any triangle. We will discuss the triangle part in the second exercise. The first exercise, we will only discuss about the shape, similar shapes and congruent shapes. Okay, so let us see the first question, which is this: all circles are dash. Now tell me, all circles are what? Are they all circles congruent or they are similar? Yes. If I say all circle means this is also a circle, this also a circle, this also a circle, this also a circle. Can I say all circle will be always similar, right? Because it is all are circles and we can say they are similar shapes. So answer is similar. Similar means shapes will be same, and congruence means they should overlap each other. So all circles are similar. All square are similar or congruent? Again, square also will be similar. All dash triangles are similar. It will be isosceles or equilateral? It will be equilateral, because see, in isosceles triangle, angles can differ. I have explained you right now. If it is isosceles triangle, for example, this is 3, 3, 5 and here it is, let's say 10, 10, 6. Is it coming proportional? Second thing about angle, let it be, is it proportional? 3/10, 3/10, 5/6, 3/10, 3/10, 5/6. Are you getting same answer in all? No. But in equilateral triangle, always you will get same answer. Okay, equal triangle, let's say 5, 5, 5, 6, 6, 6. You'll always get 5/6, 5/6, 5/6. So I can say answer is what? All equilateral triangles are similar. Because any triangle you take, any two equilateral triangle you take, always you will get same answer. Take any two equilateral triangle. For example, this is equilateral, this is also equilateral. Here it is 10, 10, 10 and here it is 3, 3, 3. I'm getting again answer 10/3, 10/3, 10/3. I'm getting all answers 10/3, 10/3, and angles are obviously equal because angles are all 60 degree. Okay. So very important thing in this chapter is to understand the fundamental of the chapter. If you are good in understanding the basics of the chapter, then you will find this chapter very, very interesting. Okay. So now the second thing is two polygons of same number of sides are similar if when two polygons can be similar if their corresponding angles are equal and the corresponding sides are proportional. Okay, so option is given equal and proportional. Where you will write equal, your angles will be equal and sides will be proportional. Sides are proportional. So on option is given equal and proportional. Where you will write equal, here you will write equal and here you write proportional, because angles are equal. Angles cannot be proportional. Angles are always equal in size, equal, and sides are proportional for similar triangles, right? So this is the definition. I can say this is the definition of similar polygons, not triangle, similar polygon. Any two polygon to be similar, it should be corresponding angles will be equal and corresponding sides are proportional. Now give two different example of pair of similar shapes. Now similar figures you can give any two examples, okay, and similar non-figure you can write one draw a triangle and one you draw a square. Okay, now in this figure you have to check now whether this figure is similar or not. Now already I have discussed how to find similar. Just have to divide PS upon AD is equal to SR upon DC, then RQ upon CB, then PQ upon AB. This is the first step. How to check any figure to be similar? First you have to check the ratio. First step. So let us check. PS is what? 1.5. AD is what? 3. SI is also 1.5. It is 3. 1.5 it is 3 and it is 1.5 it is 3. So first scenario it has cleared, it is similar, right? But the second scenario is what? All angles will be equal. But if you observe here it is 90 degree and here angle is not 90 degree, it is not mentioned. If it is not mentioned, you cannot think that it is 90 only. So directly you can say angles are not equal, therefore the figure is not similar. So I believe you have understood the first topic of this chapter, which is about similar shapes. You have to just simply understand how the shapes can be similar. It should be proportional as well as they should have equal angles. So this is what about the first exercise. The second exercise we'll discuss in the next video. Thank you.